Welcome to the video lesson on function notation and operations on functions. First up, just a reminder that this notation, which is called function notation, is read f of x, and it represents a function whose value depends on the value of x. This function is a parabola, and the y value, which is the value of the function, depends on which x value you're looking at. So using this function allows us to evaluate the function, is how it's said, at a particular x value. When I say f of 4, it means that I want to know the value of the function when x is 4. So I would take this function and replace the x with 4. Wherever there's an x, I'll plug in 4, and I'll perform the mathematical operation. 4 minus 1 is 3, 3 squared is 9, 9 times 2 is 18, plus 3 is 21. It means that f of 4 is 21. It's the value of the function when x is 4. I can do the same thing when x is -3 or any value. I would plug in -3 as an x and evaluate the function. And this one works out to be 35. That's true for any function as well. These are a couple of tests. I'll just pick one of them. Let's say 0. F of 0 means that I would replace the x value with 0 and do 0 plus 1, just 1. 3 times 1 is 3. 12 divided by 3 is 4. And 4 plus 1 is 5. So f of 0, when this is the function, is equal to 5. Another way of looking at this is visually. This function is a parabola whose vertex is 1 and 3. It has an a value of positive 2, so it's going upwards. It's a little bit vertically stretched. And f of 4 refers to the value of the function when x is 4. And if I scan all the way up, that works out to be 21, which is the same value we found when we plugged in 4 as an x value, as it should be. Okay, so that's function notation. Function operations are simply performing operations, that's addition, subtraction, multiplication, and or division on entire functions. So let's say I had these two functions. I can do this. This is actually the notation that we use. And f plus g of x is a new function of x, which can be found by taking the values of the two individual functions and adding them. I would group like terms here, and so that simplifies to this function. X squared, 2x minus 3x is negative x, and 7 plus 4 is 11. So f plus g of x is a new function, which is a quadratic, and that's what it looks like. I can do the same thing with f minus g of x, let's say. Same idea, except that because there's a minus, don't forget to distribute that negative. And again, I'd group the like terms. I could do it as a g minus f of x, and I can do it with a multiplication as well. F times g of x means that I would take the value of f of x, I would multiply it by the g function, and I'd have to double distribute this, but it works out to be a function as well. And finally, what I can do is I can take these new functions and evaluate them at a particular x value. So f plus g of 3 means taking the new function, f plus g of x, and figuring out its value, meaning its y value, when x is 3. There are two ways to look at this. The first way is if you already have a simplified f plus g of x. This would be a case where on a quiz or a test you have a part A, a part B, a part C. If you've already done the work to simplify f plus g of x, which actually for this example we did the work and figured out that that was the simplified version. If you've already done this, you would take the simplified version and simply replace in 3 as an x value. So anywhere there's an x, I'll plug in 3. I'll evaluate that. 3 squared is 9. 9 minus 3 is 6. 6 plus 11 is 17. And that is f plus g of 3. That's the first way to do this. The second way to do this is understanding that f plus g of 3 is simply equal to f of 3 plus g of 3. If I haven't done the work to simplify the two functions together, it might be easier to simply plug 3 in to each one individually and then add them. So f of 3 means taking this function, plugging in 3. I've color-coded them. This one's blue. And g, which I've color-coded orange, I would take that whole function and add in 3 as the x there. And if I simplified this, I'd get 2 times 3, which is 6, plus 7 is 13, plus 9, 22, minus 9, that's back to 13, plus 4, 17. It's the same value that we got the other way, which it should be. And that's how you evaluate an operation of a function at a particular x value.